5, 4, 3, 2, 1.
Now we turn to calculating average velocity, or the average rate of change of displacement. Example 1. What is the average velocity for an object if it travels 37.48 meters in 18.97 seconds? So once we've understood the problem, we list the data. The symbol for displacement is s. Be careful not to confuse that with s for seconds or s for speed in some cases. Time is 18.97 seconds. And now we write VF equals question mark. We're using the same symbol as for speed. Remember that in textbooks, VF will be written in bold type to distinguish it from speed, which is a scalar. In general, vectors are typed in bold. Alright, so we have our basic formula. Average velocity equals displacement over time. Substitute your data. We know the units are correct. They're in standard units of meters and seconds. Calculate your answer. Underline it. And of course, don't forget your units. Example 2. An object travels at a constant velocity for a time period of 16.54 seconds over a displacement of 19.85 meters. What is the value of this constant velocity? So first of all, we list our data. There's really no difference between the formula for average velocity and constant velocity. So we substitute our data, calculate the answer, and I've written the units as ms to the minus 1, and we highlight that. The third example is the most interesting. You'll probably recognize this as almost exactly the same as a previous example where we calculated distance and average speed. So this time we start the same way. With our diagram, it will be a vector diagram showing the displacements and times. And to get the resultant displacement, we draw a vector arrow from the start of the journey to the point of the end of the journey to show the change in displacement. And we label that S for displacement. To calculate that distance, recognize that it's just the hypotenuse of a right triangle. So we use Pythagoras and the distances, and we get a displacement of 536.68 kilometers. Now to determine the average velocity, we use that displacement and the total time of 4.5 hours to complete the journey, and that gives us an average velocity of 119 kilometers per hour. But remember that a vector is not fully described unless you include the distance. So we need to work out this angle, which I've labelled theta. The tangent of theta in a right triangle is the opposite side over the adjacent side. So tan theta equals 445 over 300, which implies that the angle is 56 degrees. You simply use the inverse tangent function on your calculator, which is usually tan minus 1 or arctan. So we include that. But here, because we're using compass directions, the standard way to write this angle would be to state it as north 56 degrees west. To understand that, the idea is that you begin by travelling north and then you swing 56 degrees to the west, and that will be your heading.